Alrighty, time to divide. But first we need to know what conjugates are. Where have we seen this before? We talked briefly about imaginary numbers. So instead of when we had like 3 plus I, it was 3 minus I was our conjugate. Oh yeah. Now when did we use them? How did we use them? It was with division. If we had like 2 over 3 plus I, we would multiply both by 3 minus I and 3 minus I. That would allow us to rationalize the denominator. Since I is the square root of -1, we had to square root the denominator. That's not cool. Well, now we're dealing even more with square roots. So if we have division and there's square roots in the denominator, we got to get rid of it. And that's what we're going to do. That's how we're going to use them now. I just answered that question because I can't ask you in a video. Alrighty, dividing radical binomials. Well, I'm going to need to multiply by my conjugate. So if I do that, I'd be multiplying by root 5 plus root 2 over root 5 plus root 2. Remember, the same thing divided, or something divided by itself is going to be 1. Multiplying by 1 doesn't do nothing. So really I'm just multiplying by 1, which isn't going to change it. It's going to look different, but mathematically it is equivalent. So what I like to do is I like to separate this into 2 problems. I'm going to do my problem 1, which is my numerator, 3 times root 5 plus root 2, which gives me 3 root 5 plus 3 root 2. Then I'm going to do my second problem, which is the denominator. I'm going to have to FOIL that bad boy. So when I do that, root 5 times root 5 is root 25, which is 5. Root 5 times root 2 is root 10. Negative root 2 times root 5 is negative root 10. And then negative root 2 times root 2 is negative root 4. Square root of 4 is 2, so minus dose. Well, the negative root 10 and positive root 10 cancel. 5 minus 2 is 3. So now what I'm going to do is I'm going to bring this back over and make myself a fraction sandwich. So we're going to take this 3 here and put it in the denominator. Well, what do you notice now? So this is what I've got going here. Is everything divisible by 3? Or am I just seeing things? Oh, wait. Everything is divisible by 3. How cool is that? So what I'm going to do is I'm going to divide everything by 3. Well, 3 root 5 divided by 3 is root 5. 3 root 2 divided by 3 is just root 2. So this whole mess over here simplifies down to this right here. That's super cool, man. That's super cool. So maybe you could try this next one on your own if you're feeling up to it. A little bit trickier with that numerator. First step, multiply by the conjugate. So square root of 3 plus square root of 5. Now, set up your 2 separate problems. Here's my first one. Now I got to distribute that 2 root 7. So I'm going to get 2 square root 21 plus 2, and then we have 7 times 5, which is 35. All right, there's my numerator. Time to set up my denom. Denom. Get it? That was cool. I'm hip. All right, we got root 3 times root 3 is root 9, which is trace. Now, what you may have noticed is that the inner and the outer will end up canceling each other. You're going to have root 15 and negative root 15, which is gone. I'm not even going to bother writing it down. Then we got negative root 5 times positive root 5 is going to be negative root 25, which is just negative 5, which gives me negative dose. So if I divide this by negative 2, what do you notice? I've got some simplifications I can do. Will this always be the case? Not necessarily. We set these up so that they would simplify. So if I take 2 root 21 divided by negative 2, I'm going to get negative square root 21. I can't simplify square root of 21, that's why I haven't done it. It breaks down to 3 and 7, and then I'm done, no pairs. And then 2 root 35 divided by negative 2 would be negative root 35. And again, root 35 breaks down to 7 and 5, no pairs. Got to leave it like that. I am donezo with that one. So these are quite a bit of work. Quite to the worka. But, you know, you guys can handle it. I believe in you. I believe in America. Jenny, how's that rope toy? She's chewing on a rope toy with a tennis ball attached to it. She loves it. All right. Peace out.